Hey guys, back to factoring. We spent a long time, the last couple of downloads, looking at what factoring means, looking at greatest common factor, looking at square minus a square, or the difference of two squares. And so today we're going to look at the third kind, which is called factoring trinomial. So everything that we start with in this type will be starting with a trinomial. Now, before we start, I want us to review something, some factoring, before factoring, some multiplication. So let's take a look at that right now. Think back with me when we had this sort of thing. We'd have something like x plus 5 times x plus 4, and we would need to multiply that out. I think at one point in time we may have called it FOIL, F-O-I-L. Many teachers call it FOIL. Many books call it FOIL. Some call it double distribute. It doesn't matter what you call it. You'd have to be very comfortable with multiplication such as this. So what I think most of you have seen is probably when you multiply the first times the first, x times x, and you get x squared. And then you multiply again. This would be double distribute, and you would get 4x. Then you would multiply and you would distribute by the 5, the positive 5, so then you would get 5x. And then you'd finish distributing the 5, you'd get 20. And then you'd say, oh, these are like terms, so I should add those together to make it more simplified. So then I would get x squared plus 9x plus 20. And so that would be a way to multiply x plus 5 times x plus 4. I'm going to do it one more way. So here's the same thing, just another way. X plus 5 times x plus 4. And a lot of books, and this is the one that I referred to as FOIL, so you would multiply the first times the first, and you would get the first term over there. Then you'd multiply the two outside. These are the two outside ones, so you multiply that one times that one, and you get positive 4x. You'd multiply the inside by the inside, and you would get 5x. And then you would multiply the last one in this parentheses by the last one in that parentheses and get 20. So if you're new to this, your head may be swimming right now, but it will become second nature if you practice, which you must practice to get this. Then you add up your like terms just like we did before, x squared plus 9x plus 20. So you certainly see that you get the same answer whether you do it by double distributing or whether you FOIL to get your answer. But if multiplication is difficult for you, if that is difficult for you, then you must stop, spend some time with this, process, or even better, go back to the track that talks about multiplication in algebra until you get this step down. Because you will not be able to factor, which really means to do this process in reverse if you don't understand it straightforward first. So let's take a look at let's assume that we're all together now, and let's just get started on what this type of factoring is. So let's suppose that we have x squared plus 7x plus 12. As I said, this is factoring trinomial. So you see that what I just put up here is a trinomial. And so let's see if we can factor it. Does it have a greatest common factor? Is there anything they have in common? No. All right, is it a difference of two squares? No, it's 3. It's 3 terms. So I usually say in this one also make a skeleton and kind of start off like that. Then I say, okay, what times what will give you x squared? And the answer I'm looking for is x times x will give you x squared. So I can put those in here and know that I'm right. Okay, now, I'm like, well, because I learned up here that this term times this one is supposed to give me x squared. And this end one times that one is supposed to give me the end one, which is 20. So I just need two numbers that are going to multiply that are going to give me 12. So you think, okay, maybe you want to put 12 times 1. Maybe you want to put 3 times 4. Or maybe you want to put 6 times 2. And those are the only choices. But any of those would give you 12. Now this is like a puzzle, so if you like puzzles, you're going to like this. It really is like a puzzle. All these aren't right, only one of them. You have to choose the one. You have to choose the one that when you add these together or subtract them, it will give you this number right here. So when you take a look at that, you're like, well, there's no way I can get a 7 out of a 12 and a 1. And there's no way I can get a 7 out of a 6 and a 2. But there is a way I can get a 7 out of a 3 and 4. I could add them. 3 plus 4 could get a 7. Those are the ones you use. So I go plus 3 and plus 4. Now maybe you're saying, could you have put the 4 here and the 3 here? Yes. Doesn't matter. And then maybe you're saying, well, how did I know these were positives and not negatives? Well, that's when this up here comes into play, because we have to check this every time or we will not know if we're getting it right. If we just make a wild guess and walk away, we will not have a clue if we're right or not. So we must check it. How do you check it? Well, watch. Here we go. Get this out of the way. All right, so to check this, we're going to multiply it back together and see if we got what we started with. That's all. Because this has to mean the same as this. So if we multiply this out and we don't get this, then we're wrong. If we multiply this out and we do get this, we're right. So let's settle in on, that's why I said you have to really be good at multiplying those. So here we go. I'm assuming you are good by now. You've stopped if you weren't and you practiced. So here we go. We're going to multiply this out. So we go x times x, and we get x squared. And I come over here and I say, ooh, that is great. That's what I was hoping to get. And then I'm going to do as many shortcuts as I think will help you without confusing you. So then we go down to this number times this one, positive 3 times positive 4, positive 12. There it is. Yay, that worked. Okay? But the catchy part is this right in here. This right in here. So now I do these two inside ones and I get positive times positive, I get positive 3x. And then I do these two outside ones, the x times the positive 4, and I get positive 4x. And I combine those. The signs are alike, so I add them, I get 7x. That is what is in the middle. So everything checks. Everything worked great. So we're done with that problem. We factored it, we checked it, all was well. It may have felt like there was a little bit of guesswork in it when we listed these possibilities, and I suppose you could say there is, but we make an educated guess because we know the power of this number in the middle, and it's going to help us choose the right guess, if you so to speak, but we're definitely checking it. Okay, let's just do a few of these and see if we can kind of get the hang of it and go from there. All right, here's another one. You know I'm going to start with some easy ones, so enjoy these. So here's one, x squared plus 8x plus 15. Okay, first of all, I'll see if it has a greatest common factor. I want that to be a habit, and no, it does not. So we go on, it's a trinomial, so we put our skeleton, and we say, how do we get x squared? That's a no-brainer. X times x. Okay, how do we get 15? So our brain thinks, how do we get 15? Well, we could go 15 times 1. We could go 5 times 3. That's it. You're like, okay, I got a guessing, and I'm to the guessing stage? Not exactly, but you do want to choose one of these that will either add up or subtract to give me a positive 8. So clearly, which two numbers do I use? Yeah, I use the 5 and the 3. So I use plus 5 and plus 3. Now, we got to check that to make sure, we just have to check it. Signs, numbers, too many places to mess up. But we can check it easily. We go x times x, yep. Positive times positive 15, yep. Then we check in the middle. Positive 5x, positive 3x, positive 8x works. Works. Great. So as long as, you may be getting it now, that as long as everything is positive, hey, it's a lot easier. Let's do one more positive one. Let's say that we've got x squared plus 6x plus 9. And again, we've got everything positive, so we don't even have to think about signs. Everything's going to be positive. No greatest common factor because there's only a 1 there. So here we go. So for x squared, we understand that it's x times x. Now for 9, we could put 9 times 1 or 3 times 3. And you're already getting, I know you're getting it so well that you know that because it's a 6, we've got to put 3 and 3. And because these are both positive, so are these. And so we get x plus 3 times x plus 3. Then we check it. X times x is x squared, checks. 3 times 3 is 9, checks. Check in the middle. 3x, positive, and positive 3x is positive 6x works. Okay? You got that? Good. That's the basis. All positive, everything works, good. Okay? We've got to get that first. But I think we're due. I think we're okay on that one. So now let's take one just a little smidgen bit, maybe just a little smidgen of a bit harder. Let's suppose that we've got one that says x squared plus 2x minus 15. Okay, as soon as you look at it, you see it's different in that it has a negative here. So yeah, it's going to take a little more thought. But we approach it the same way. We look for the greatest common factor, determine it doesn't have one. So we go with our skeleton. We say, well, the x squared part is easy. That's x times x. Now here we go. Don't worry about the signs yet. 15, we could be 15 times 1, or we could be 5 times 3, and that's all. Now we're trying to either add or subtract this pair of numbers so that we get a 2. And we've got to get a positive 2, by the way. So I think it's pretty clear that you're not going to get a 2 out of 15 and 1. Right? But if you've got a 5 and a 3, I could subtract and get a 2. So this is my best guess. So I'm going with the 5 and the 3. So I'm going to put the 5 and I'm going to put the 3. Now notice I haven't put a sign yet because I might not be sure. Okay, now look carefully. I'm supposed to get a positive 2 in the middle, right? Okay. Well, how is the only way that I can get a positive 2 out of 5 and 3 when I combine those? The only way I can do it is if I have a positive 5 and a negative 3. Because what is positive 5 and negative 3? Positive 2, right? So that checks. Now let's check the rest of it. X times x, x squared. Yes. 5 times negative 3, negative 15. Easy part. In the middle, careful, 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 careful. Positive 5x. And going that way, negative 3x gives me a positive 2x. And that's what I wanted to get. So the sign is very, very important. Very, very important. All right? As soon as there's a negative here, these signs are going to be different. One is going to be positive and one is negative. Now somebody else on this problem might have put x minus 3 first and then x plus 5. And that would be okay. It's just that the 5 has to be the positive in order for this one in the middle. So whatever sign this middle term has, then the bigger one of these two will have that same sign. There are a lot of rules you can learn, and you will learn over time, but in the meantime, you can figure them out probably just as easily as you're trying to memorize a bunch of rules. So right now, I ask you just to try to understand the process. So let's go it again. All right, this time let's take x squared minus 8x minus 20. And we've determined there is no greatest common factor, so we go straight to the parentheses of the skeleton and we put in what we know, which is x times x, and we go, stop. That's all we know. Now we're like, how can we get 20? Well, here are our choices. 20 times 1, 5 times 4, and 10 times 2. And that's it. That's the only thing we can factor, only way we can factor 20. All right, now which pair of numbers can I either add or subtract to get 8? And I bet you said 10 and 2, and of course you said 10 and 2 because you can't get an 8 out of the other two. So what goes here and here? 10 and 2. And again, it doesn't matter which one goes first. Right? Okay, now let's get our signs right. Well, it's got to be a negative 8. And we've got to subtract the numbers, because if we add them, we're going to get 12. So we have to subtract them, which means one sign's going to be negative, one's going to be positive. And this sign is going to go with a larger one. So here we go with a negative 10 and a positive 2. Now let's check. X times x, x squared? Yes. Easy part. Negative 10 times positive 2, negative 20? Yep, got to be good at signs. Okay, in the middle, watch this part carefully. Negative 10x, and front and last, positive 2x, combine, sign of the larger, negative 8x, yes, success. So everything works good. So you see how it works out, but we need to do another one or two of these. So let's go. Let's say we've got one that's x squared minus 5xy plus 4y squared. Now this one looks way different. I realize that. So stay with me carefully and we'll work through it. We'll see that the process is the same. But first of all, we look really, really carefully to see if we've got a greatest common factor that's common to all three terms, and we don't. This one doesn't have a y, this one doesn't have an x, and so there's nothing in common. So here goes our skeleton here. Easy part, x times x. Now that's kind of the end of the easy part. So we're like, all right, how can we get 4? Well, we could put 4 times 1 or 2 times 2. That's the only ways. Now, which one of these can we either add or subtract to get 5? Would it be 4 and 1, or would it be 2 and 2 to get 5? It would be 4 and 1. So those are the numbers we're going to use. We're going to use a 4 and a 1. Now I made this one a little differently also, because instead of just x squared on the front, I put y squared on the end. So we're going to have 4y and 1y. Because the only way that it can check back and be y squared is if we have a y times a y. Do you get that? 4y times 1y is 4y squared, and that's what it has to be. So if there's squares on the end and another variable, if they use 2 variables, you use 2 variables. Okay, now let's check it, because we don't have our signs yet, so we have to be careful about this. Our middle sign is a negative. So the only way that we're going to be able to get a negative out of these two, are we going to want to be adding the 4 and the 1 to get a 5, or subtracting them? Adding them, because if we subtract them, we're going to get 3. It's the only way we can get 5 is to add them. So the signs have to be the same, because if the signs are different, you subtract. So the signs are the same as whatever this one is, and it's negative. So we got negative, negative. Now this is a little bit of trial and error. And to you it may feel like it's a lot of trial and error, and in the beginning it is. But we're going to check it, and then if we have it wrong, we'll just fix it. But let's see, you have to check it every time. All right, here we go. So we got x times x is x squared, and that's the good part. We knew that was right anyway. Yay! Okay, and here, negative 4 times negative 1y would be negative times negative positive 4y squared. Good. That's good. Now let's get the middle part. That's usually the tricky part. So we go right in here and we say to ourselves, or we just say that's negative 4xy. And then we go the other way. The first one and the last one. We go negative 1xy. And the signs are the same, so we add those up, and then we get negative 5xy. And we hope to goodness that that's what's in the middle over here. And we look over here, negative 5xy, negative 5xy. Yes, and we are happy. We are happy campers because it checked out. If it did not check, we would have to do a lot of experimenting and trying something else and finding something that would work. And on the next tape, we will be doing a lot of those kind where the factoring gets very complicated and gets all mixed up. But this is a little bit of factoring trinomials with different cases of signs. Let's try one more. I always say let's try one more and then we end up trying 3 more, but that's okay. Better too many than not enough. Alright, let's try another one. Let's say we've got x squared minus x minus 30. Alright, and we look for greatest common factor. There's not one, so we go straight to this part. We go straight to the easy part, get that out of the way. X times x is x squared, and now we're with our numbers. You know, I don't really think about signs at this point. I just go straight to the numbers. So our possibilities are 30 times 1, 15 times 2, that would be 30. 10 times 3, that would be 30. 4 won't go. 5 times 6, that would be 30. I think that's it. I think that's all I want. So we got to pick one of these is right, all the rest of them wrong. So which one of these is either going to add or subtract to give us this? And you're like, well, to give us what? Well, it's like a 1 there. So one of these pairs is either going to add up to 1 or subtract to 1, and that's the pair. That is the correct one. So the only one that we can get a 1 out of if we add or if we subtract is which one? The 5 and the 6. You would be so right. So those are our numbers, a 5 and a 6. Notice I didn't give any thought to which one I put first, because it doesn't matter. I just said a 5 and a 6. Popped them in there. But the sign really matters. So let's look at that. What we're supposed to get is a -1 when we subtract those. So for us to get a negative, the larger number, 6, has to be a negative, because it's always the sign of the larger. And then to get a -30, it has to be a positive times a negative. So that is my best guess. You don't always get it right on your best guess, on your first guess. I should, because I'm the teacher. But you know, when you're beginning, you don't always get it right on the first guess, and you have to check and check and check sometimes. So let's check this anyway. Check every time. So x times x is x squared. We were sure of that. Let's do the other end, -30. Watch your signs, you know, positive times negative is negative. Now check the middle. Right here, I get a positive 5x. And then I check first to last, -6x. And I'm trying to get a 1. I say, can I get a 1? I get -1x. Yes, it all checks out. If it doesn't, I get my eraser and I start over again. And I just try to find my error. Rather than finding my error, I find it easier just to start over again. Let's do another one. Let's say that we've got, I'm going to throw in a greatest common factor here. I'm going to say that we've got 2x squared plus 4x minus 30. And I'm hoping I'm making up a good problem. I hope so. Anyway, you look first of all and you're like, do I see a greatest common factor? I'm telling you yes, so what would it be? What would go into all 3 terms? 2, perfect. So here's our new problem. Factor out the 2. All right, let me hear you. What do you have left in there? Yeah, what next? Right, what next? Right, perfect. Okay, now here's the deal. If you factor out that 2, it is always going to be part of your answer. So you don't drop that off or forget that it ever existed. That is part of your answer. Okay, now I put my 2 skeleton deals in here, and I don't really have to look up there right now. I don't want to get confused about looking up there. I've created a new problem here, and that's the one I'm factoring. So to get x squared, I get x times x, and to get 15, again, it could be 15 times 1 or 5 times 3, and so you're looking not up here, because you already changed it to this. So to get 2, it would be 5 and 3. And you need a positive 2, so you take the sign of the larger number to be positive, and the other one negative, so you can subtract those, and then that would be your final answer. So if it has one that is possible to remove a common factor out to begin with, do that. It makes it ever so much easier. So always be on the lookout for greatest common factors, like the very first thing that you do. Maybe one more. Are you up to one more? Let's do another greatest common factor one. Let's say that we've got 3x squared, 6x plus 3. And I know that it just jumps out at you what the greatest common factor is, doesn't it? Yeah, it's 3. You can just see 3 going into everything. So you take out your 3, you got x squared plus 2x plus 1. You take something out. I mean, every time I say that, now remember I'm dividing. So 3 divided into 3 is 1. You don't leave it blank. 3 divided into 3 is 1. And again, once you take out or remove or divide out, or however you choose to phrase it, once you find your GCF, your greatest common factor, it is part of your problem. You never drop it off. So I write it down. It's a very important part of my problem, of my answer. And then I look at what is left here. I don't look up here. I've changed that to this form. There's the 3, so I don't try not to look at it. Make it simple. So to get x squared, I go x times x. And to get 1, I go 1 times 1. That's the only way to get 1. 1 times 1. Now let's see if it checks back. And then to get 2, I would have to add those two 1s together. Remember, if these are both positive, shortcut, those are both positives. So there you go. And that x squared, 1 times 1 is 1. 1x and 1x is 2x. 3 times x squared, 3 times 2 is 6, 3 times 1 is 3. Everything checks and everything is wonderful. So I hope that this gave you a good overview of factoring with trinomials. In the next download we'll try to put all of these different kinds of factorings together for a little more advanced view of how it works out in real life. Thanks, take a break, come back another day. Bye-bye.